I'm CK. Today we've got another kit from Gikfun. This is a warning light flashing arrows thing, a little LED kit. We'll see what else it comes with, see how it goes together, see how much fun it is, and what we learn from it. And I hope you enjoy the video. Let's see what's in the bag this evening. First, we've got a piece of paper. And it is flashing lamp kit. I don't know what it actually does. Need a soldering iron, solder, multimeter, pliers, tweezers, and good step-by-step pictures. Oh, and here we have the little arrows you can put on there. And a good schematic. And it's got, let's see what we got inside the bags. First, we got another bag that I'll try and get open. Come on. Battery box for 3 batteries, so that's 4.5 volts, so we can use USB power for that too, can't we? Just in case we want to. Looks like some red LEDs based on the red dot, and some blue LEDs. Get rid of that bag. Let me get my LED buddy out. Oops. Which I made about 2 years ago now, maybe a year and a half ago now. And you can look at the video on my channel and get one of these if you work with LEDs a lot, because it's really fun and it's really useful. So take out one LED, it's supposed to be a blue one. Let's see what it looks like when we put it on there. Nice and blue. 3.1 volts at 5 volt input. Takes 3.1 volts to light it up. 26 milliamp and 68 ohm current limiting resistor. If you want to calculate that, it does it for you. That's the beauty of this little device. Now we'll try a red one. And that's 2.1 volt. That's 1 volt less. Blue LEDs take a lot more power than anybody else. Go look up the history. Blue LEDs were really hard to actually finally get done. It wasn't until the 90s when they figured out how to do that. Then in here we've got all the bits and pieces. Got one circuit board, the main circuit board. So as I kind of thought, we have a 555 timer. Then we've got 2 CD4017s. Those are counters, so the 555 timer will be pulsing out pulses feeding into the timer, and the timer will light up the LEDs as appropriate. I don't know what it's actually supposed to do, but we'll figure that out as we get it together. The board's pretty good. Board's better than some of these inexpensive kits. Through-hole plated, even though it's only single layer. Actually, it's not through-hole plated, is it? No, it's just surface plated, but it's not just copper, it's silverized. So that's nice. Takes 3 to 6 volts in. Switch, capacitor, variable resistor. All the values of the componentry is on the board. There's 1, 2, 3, 4, 5 transistors to set up the logic. As you can see, the 555 timer puts the out in and pulses into the 4017, 2 of them, and which feeds the diode. The transistors hits the output Q0 through 4. It looks like they're using Q0, Q2, Q4. Doesn't look like they're using all of them to pulse the gates and let current flow through those diodes. And then over here, the other 4017 is kind of skipping output pulses from the clock. Interesting little circuit. Kind of neat. Now we'll pour the rest of this stuff out. Don't lose that diode. Got some resistors, some wire to connect everything up, a couple of arrows. Here are the 4017s, kind of locked together. Try and get them apart without damaging them. Oh, come on, guys. This is silly. Ah. There we go. Let's see, they are from... it's got, this is one of those cute ones. It's got an outline that's somewhat reminiscent of the state of Texas and some characters on it, but these are not Texas Instrument parts. These are knockoffs. And the 555, same thing. I don't know who makes them, but it certainly is not TI itself. And we've got some connectors to go to those arrows. There's the variable resistor. Electrolytic caps, 2 of them. Probably one's to set the capacitor side of the 555 timer, then the variable resistor will feed the other side to set the timing on the 555. Some diodes, transistors. Here's one 104 disc cap. There should be 2 since we've got, actually there should be more than 2. That's interesting. They're not using decoupling caps on the ICs at all. I don't even know where this 104 goes. Where does this 104 go? Oh, there it is, over here. And that's feeding into, so that is feeding in to the 555, but there's no decoupling caps for the CD 4017s. Just interesting. So it looks pretty straightforward. I'll get the soldering iron heated up and we'll start putting this thing together. One thing I didn't look at is whether all the transistors are the same, and they are. They're all S8050s. And we will do what we do, which is we'll start with resistors, and we've got these 1Ks, and we've got these 22 ohm resistors. Where do the 22 ohms go? They go in R8 and R9. I wonder what they're for. Let's take a look. So R8 and R9 are right there, which doesn't really give me a good clue. You know, and this is interesting. Oh, I'm sorry, that's not interesting. These are where the arrow boards go. I was saying, that's interesting. I don't know what these outs are for. They're for the arrows, buddy. Golly. So we'll do the resistors first, as is our wont. We'll do the 1Ks first, simply because there are more of them, and I like to do the more components first and then go down to fewer and fewer. Just my habit. No particular reason. I just find it more satisfying that way. So first we do 2 things. We'll see, number 1, how the resistors, how close to the body you have to bend the leads of the resistors, and it looks like pretty much right up against the body is just fine for these. And I'll do one live and in person. And the circuit board takes solder very well. That's good. So I'll do the rest of the 1 5K resistors and the two 22 ohm resistors, and we'll do them in fast motion. And I'll mute the audio because there's not much more to say about them. Gives you a chance to enjoy resistor time. And that's resistor time for tonight. Let me zoom in a little closer, just a little bit. Now we'll do all the diodes. I believe there are, how many of them? 6 of them. 1, 2, oops. And they're pretty much like the resistors, except we have to pay attention to where the silver stripe on the diode goes. It'll go towards the line on the circuit board. And these are ostensibly 4007s, but I haven't seen. This package is a little, the stripe is different and the diameter is a little less than 4007s that I've used in the past. There's the diodes, and all the cathode ends face the same way, which is nice. Now his next, oh, I see why. His next step is to install the triodes or transistors. Again, I don't agree with that translation that they use. Usually we'd put the chip sockets on now, but as you may have noticed from the parts breakdown, there are no sockets here. We're going to be soldering the chips directly onto the board, which is A-OK. So we just make sure we get the flat side of the transistor facing the flat side of the outline of the transistor printed on the circuit board, and put them all on. That's all the transistors. Now we'll put the two electrolytic caps on, and they are polarized, as you probably know. So we want to make sure the long lead goes where the plus sign is, and the short lead and the stripe side of the capacitor goes to the shaded side of the outline. And we'll put this little 104 on, which again I guess is decoupling. It's decoupling the power into the 555 timer, but we don't have corresponding decoupling caps for the decade counter divider. Now we'll put the variable resistor in. Goes in just one way because of the way the legs are spaced. Don't have to bend that. It'll hang right on there. And then the next thing would be the connectors, but I'll solder these little fellows on before I get to the connectors. Now we'll take a look at the connectors. And it's got three things to notice. Well, two things to notice. You'll notice that there's a little cutout marker on the circuit board, and that will go with the little cutout in the socket itself. And we can verify that if we want. Just always kind of fun to do. Take the connector and put it in kind of halfway, just so you can hold it in place. You'll see where the red wire is, which is the positive wire. And you'll see if we put it in the way we just described, that goes to the positive. So it's easy to get it right and see what's going on. Let me see how tall these are. Are these taller than the caps or the transistors? They're not taller than the caps, so I got to do them one at a time. I was going to put them all on at the same time, but since I can't press them all flat against like an index card to flip them over, I can't do that this time. The cable seat cannot be installed reversibly. In other words, put it together right, or else things will be bad. Next, we'll find our little power switch. They didn't give us a button cap. That's too bad. And this also has a little notch. You'll be able to barely see it here, but there's a little notch in the bottom here that goes with the little notch on the circuit board. Now this is probably the hardest thing to solder because these pins are so close together. So what I'm going to do, so I'm not holding it with my pinky finger, I'll do one leg. I got too much solder on my soldering iron. Do one leg, make sure everything goes flat by pressing the button down, reheating that solder, and it went all flat. Wait for the solder to cool. Now I can do the rest of these pins. Making sure I didn't bridge anything. Touching up that piece of solder right there a little bit. There we go. And now we'll put the ICs on. Legs are a little cattywampus. God, this 555 chip looks a little ratty. Gonna straighten it up with my needle nose. Straighten the pins up. Get the notch on the chip matching the notch on the circuit board. Making sure we can get all the pins in. I may have bent them in a little too much. There, that goes in reasonably well. I'm going to tack one leg down, or pin. I never know what to call a chip attachment. Put the two CD4017s on. Chips are tacked in place. The notches are on the right way. One thing I will notice, again, these are knockoff chips. The epoxy is not very sharp. There are no sharp edges. Everything's kind of blurry. Now I'll do all these pins. And that is that for the board. Got power coming in here. The 555 timer is being driven by, or being speed controlled by this resistor in one of the caps, feeding these two CD 4017s, going ping, 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 ping. These are counting them up, and then as they count them up, they'll feed the various transistors through the diode sets and send the lights out to the, or send the power out to the arrow boards. And it's set up so I'm gonna recycle the cameras and then we'll do these arrow boards. And as you may imagine, we're going to do one red and one blue, and as you can imagine, this is going to be pretty much the same thing over and over again. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 16, 19, 22, 25 LEDs per. Now I could test all the LEDs before I put them on, but I'm not gonna. If some of them fail, that's okay. So when we actually get this working, I'll show you what it's actually doing, or how it's working, because as you can see, there's only 2 wires going in here, and these are going to be operating sequentially, I believe. At least that's what the circuit tells me. So the LED symbol is on the board. The flat bar is where the short leg will go. It's also, there's a flat side on the LED. So you just put it in that way. And to make this nice, what I do generally is I'll do one leg of the LED, pick it back up, press on it with my index finger, reheat that solder a little bit. I felt it move a little bit, so now it's completely flat on the board and will be attractive, and they'll all match up. Now, I'm going to be doing 50 of these, and there's not much more to say than what I just said. So again, we'll go into fast playback and mute the sound, and we'll have a little LED time tonight. A 100 solder joints later, and we've got both arrows done. All the LEDs look pretty much in alignment. Actually, these two don't. Am I going to nitpick about that? This one looks all good. This one has got 2 that you can't, you in the viewing audience can't see because they're so slight, but I'm going to go ahead and, there, I felt it click. That's good. Always good when you feel it click. And now this one. I'm heating both solder pads at the same time. There we go. That one clicked too. That's one reason why I use this tip, because it helps me. Now we'll put the wires on. Oops, don't put it through the hole that doesn't have any solder pad. I gotta get my locking, gotta drop my locking tweezers to keep this wire going through the hole. Red wire through the plus sign marked pad. And there's those with the wires on. Oh, by the way, gave me 2 each extra of LEDs, 2 extra blue, 2 extra red, which I probably won't need, so I'll put them in my spare parts box. Click in these 2 things. Now, at this point we're going to be powering it, and I could either connect this battery box, or what I'm going to do is I'm going to connect this to an external power supply, so I don't have to fuss around with batteries. So I'll just click that in and click the connect the power supply to that, which I'll do in a second. Let me get all set up. So I'll turn off the cameras for a minute or two. Turned my overhead light off. Got the 2 arrows set up. Let's turn the power on. See what it does. I've got it connected to my little power supply here. There goes the red light. Red light's blinking as the 555 counts up and tells it to blink. Now it's taking a little pause. Now it's doing the blue one. Now it's counted up to a certain amount, and it's probably going to change the pattern. There we go, because now we've got more lines from the CD4017s being pinged, and that's turning on the transistors, as you can see in the schematic, and that's what turns on the arrows one by one, or 2x2 or whatever. Gosh, it sure does take a long time. Come on, little fella. It's like it's in... There we go. Let me turn the variable resistor to the middle. Now it's going a little faster. Turn it all the way counterclockwise. And now we're flashing. Now we're really flashing. So again, just look at the schematic and see how the 555 timing is being set by this variable resistor. As you can see, where is it? There, it's this one right here that's changing the trigger value with the caps and the other resistors. And then that's going out into the, where is it coming in? Going into the clock there, and it's counting things up and triggering things along the way. So that's what it does. It certainly is a good solder practice kit. Soldering 50 LEDs is going to be good solder practice no matter what. Getting all your diodes and transistors pointed in the right direction and seeing how you can change the frequency rate of a 555 chip, which you will see in many designs of many things. So get familiar with it. So it's kind of fun kit, and it goes flashy. And as always, I hope you enjoyed the video.